When we're dealing with slope, and I can't get all of Mr. Slope Guy's interesting information on here, but we'll get it as we start adding stuff to his face. This is going to be kind of your cheat sheet for slope. You can use Mr. Slope Guy whenever you want to in any quiz or test we do in this unit, in case you're having issues with things. So here's how he works. He basically tells you everything you need to know about slope with his face. For instance, when a line goes up to the right, okay, it has a positive slope. Well, you'll notice his left eye is a plus sign, kind of goes along with something being positive. His right eye is going down to the right, which is equivalent of negative slope. And his right eye, looks like it's closed. Maybe he's winking at you, okay? But again, the minus is like a negative, okay? It gets better. His nose is a vertical line. Right. When you have a slope that's vertical, okay, and we'll even put that in here too, just to remind you of what direction this is. A vertical line is undefined, so the bottom of his nose is shaped like a U to remind you, okay, if I see a line that's going up and down, it has an undefined slope. And then finally, his mouth has a zero slope because it's a horizontal line, and we'll get into this more in depth. But right, his little dimples there on the side are zeros to remind you that when you have a flat, what's that? Undefined. So, for instance, if I tried to figure out the slope, calculate the slope on a calculator, for a vertical line that goes straight up and down, I get an error message. But if it's going side to side, I get 0. So this is kind of to start helping with some of those detail things that sometimes we may not think about when we're doing something like this. So again, switch this up a little. Yeah, Mr. Slope Guy. Keep him around. He can help out with things. Okay? Now, along with Mr. Slope Guy, well, I'm going to put Mr. Slope Guy off to the side here for a minute. He may make some appearances again here. That's all we need to write on him for right now. We may put some more stuff on him here in a minute. May give him some like cheek tattoos or something with the slope formula. We'll see. But for now, what we're going to do is we're going to flip to that other page, which you hopefully picked up front, and start actually putting some of this to use. So if we need Mr. Slope Guy back up in a bit, we'll get him back up here. But for the time being, we'll slide this down a bit. We're going to get a little bit into actually some different ways I can find slope. Sometimes it may be a picture. Sometimes I may not have a picture, and I'll actually have to do a little bit of work on this. So here's how this is going to work. When I'm trying to find my slope, one of the ways I can do it is in a formula type thing. Okay? It's the change in y over the change in x. And when we actually get to doing slope formula, our y's are going to go on top of our fraction. Our x's are going to go on the bottom. Another way it may have been explained to you before, or that I'll use in here, is the change in rise over the change in run. And those are the two basic ways we're going to talk about it. I'm not going to get into a whole bunch of other fancy talk, because that just makes things more confusing. So, slope can be found in equations, like the ones right below here. But I'm always looking for that next to the x. Okay? X itself is not included in slope. It's just the number in front of it. Okay? So put that in here too. Okay? The number in front of x is what we're looking for. So no matter what the equation itself looks like, all I have to do is find the number in front of x, and that's my slope. Now we'll start talking about how I like slope to be a fraction, but for now that's fine. So what would the slope be in letter B? Okay, but take the sign along with. Okay, so my slope would be -3. What about for letter C? 2/3. Okay, and you start to see one. I'm just gonna roll. Ooh. What about E? Okay, good. In E, even though I just see the 2 here, remember, whenever you're looking at any type of a fraction, if I don't see a number, there's a 1 up on the top of it. So, my slope here would be 1/2, which should make letter F a little easier to work with. Okay, but it's the number always that's right in front of X every time. So what about F? Yeah, right now we're just determining what the slope is. 1/3. It's just that number that's combined in with my X that's in front of it. -3. 1. Negative. Nope, exactly. -1. Because again, if I don't, again, the number that's right in front, that's directly connected to it. 5's close, but it's not as close as the -1 is. Okay. 0, yeah. Now here's something we want to talk about a little bit. When I get to J and K, you're like, well, J, there's no X anywhere. That's true. It's going to end up being 0. So we're going to bring Mr. Slope Guy back here for a minute. When I get to a Y equals, and there's just a number there, there's no X, right, what I'm going to do is, these are always going to be my Y equals and just a number type equation. If I see Y equals and a number, it's got a 0 slope. So right, the slope for J would be 0. For K, whenever I see an X equals and a number, nope. Because here, and that's a good way of looking at it, I like the way you're thinking with it, undefined is going to be my X equals. No, it would actually be undefined. You can just put UNDEF, that's even UND would be okay. And here's why that is, because some of you may say, but I see an X and there'd be a 1 in front of it, so what's the deal? The only time that works is when I have an equation like the rest of them that are what's called slope-intercept form, and I have Y equals and then I get an X. If it's just X, it's just going to be a straight up and down line. Okay? And that'll always be undefined. So again, this can kind of help out too, and I'm glad we kind of got that on Mr. Slope Guy there. But what if I'm not given an equation? You know, is there another way that I can figure out what my slope is going to be? Sure, there is. Graphing. So, my slope can be found by drawing a set of points, okay, a set of dots, along my line. And then I can figure out the change in the vertical, which is my Y values, direction, and then use that for the numerator, because it's going to be a fraction, and I can count the units, yep. A change in the horizontal, which is my x's, and use that in the denominator. So we're actually going to start making a fraction out of that. And whether that's in an equation, like we did up in the second section, or like it's going to be as points, like we do here with the graphs in section 3, we're just going to kind of count on. So here's kind of what we're up to. Yep, and there's 2 things I want you to do here. You'll notice also it mentions determine the type of slope. So you can use Mr. Slope Guy if you need to. If my line's going up to the right, what type of slope is that? Positive. Okay. So I have positive slope. And then right. Like Mike had said, here's something I can do. I can choose any 2 points I want on the line. And I kind of end up making a little triangle out of the deal. And what I'm going to do is, I'm going to count how far do I have to go up and over, down and over to get from one point to the other one. So what we've got, nope, nope. Uh-huh. So, let's say I'm going from here to here. And I go up 1, that'd be the top of my fraction. And I'm going right 1, which is also positive. So my slope would be 1 over 1 or 1. Okay? And I really do want you to try and keep your slopes as fractions, because that'll really help when it comes to graphing on these. But if you just put 1, that'd be okay. Not every time, because if we go to the next one, let's say I'm here. First, yeah, we got to connect points. Okay, no, they still got to be points that are on there. So right, first thing, okay, right here, since my line's going down to the right, it has a negative slope. But like was already mentioned, again, the number on top is how much I go up or down. So 1, 2, I go up 3. That's my top number. But then I go, well, basically what I'm doing here, and all I'm doing, is I'm finding, you notice how there's 3 kind of bigger dots on my line? Basically, that's what we're doing, because we're taking 2 of the dots, and then we're basically just going to go from there, and I can either go up and over, okay, to connect the dot here, or even if I were to go down and over here, I'd actually get the same answer. Yeah, but it's going to be the same either way, because I'll show you. If this one I go up 3, and then I go left 1, well, going left on the x-axis is negative. So I'd have a slope that's 3 over negative 1. Right. So let me show you another one so you can be like, oh, so I can get away with doing that. Yeah. So let's say I'm on the exact same problem even. I chose to do these. Well, you say, well, I don't want to do those 2. I want to do this dot to this one. It will. Because here, now, I'm going down 3. So you're like, okay, this is going to be different because that's negative 3. Yeah, I could do these 2. Uh-huh. Yeah, you need to pick 2 points, and they wouldn't have to be right next to each other. I could still simplify it, but it's easier. Right. Yep. You absolutely could. That's why I'm saying any 2 dots on the line will get you to the right slope. But it's easier to do the ones that are closest to each other because I won't have to reduce the fraction at all then. Right, but they will get me to the same spot. So even if, for instance, let's say, well, let's just do that for once. Let's say I want to use these 2. I decide I don't want to use the 2 that are right next to each other. That's boring. Let's try something different. So I tried these 2 out instead. Let me try to, let's jumbo size here so we can see a little easier. Well, no, there's one in between here on this one. So here, right, I went up 2, and I went right 1, 2, 3, 4. Now here's my dilemma with not using them that are right next to each other. Can I reduce 2 over 4? Yeah. I can divide each of those by 2, which is a half, which is the same thing I'd have gotten if I'd have taken a different couple and I'd have used 2 right next to each other. So I went up 1 and right 2 if I'd used a different 2 points. And it's still a positive slope that's going up to the right. So that's kind of how this works. But any 2 points will work. It just depends on if I've got to reduce it or not. I'm going to zoom back out here a little bit. So we've looked at an equation. I looked at the number in front of x. That's one way to find slope. If I have a graph and I can look at the points, okay, I can count. Here's my other option. You're like, dang, there's a lot of options for this. There's this formula. That's true. So here, my biggest thing I got to remember is twofold. One, that I'm subtracting my values, and number two, that the y's are on top every time with these. So what I would suggest is when I went to do these, I would label my y's first, and order does matter to some point, so what I'd suggest for most of you is that the second y you see here is one I'd label as y2. So then, when I go to put them in the fraction, into my equation, so my y2 is 8, my y1 is 3, and when I go to do my x's then, you keep your x's in the same order. So if I did this y is my y2, this has got to be my x2. So, 2. Yep, we put the y's together up top. Huh? Because that's what my actual formula is here. This is the formula. And we're going to use that every time. And when you're doing slope, if you get to a fraction you can't reduce it, like 2 doesn't go into 5 evenly, then you're done. You don't want to make it like 2.5 or 2.5. That's really hard to grasp. So if we get a fraction, it doesn't go any further, we're just done. And that's going to be the same for every one of these. I always want to put in my bar with my subtraction sign. And again, I look at my y's, and I'm going to subtract those. And then I'm going to look at my x's, and I'm going to subtract those. As long as you take your time. Yeah, either order on these I could do. I could do 0 minus 1 as long as I did 5 minus 6 then. I've got to use them in the same order, no matter which way I choose to do that. And I'll get to the right answer. So just as an example, I'm hoping this doesn't freak some of you out. What if I chose, instead of doing it this way, say, okay, here's my y's. Well, I want to do this one first. I can. Okay? If I wanted to do this y first, and do 4 minus negative 1, that is this one minus this one, that's fine as long as when I do the x's, I do the same thing. So I do negative 2. Right, and I'll get the same answer either way. Because what happens when I minus a negative? That becomes plus, so that's 5. Which would reduce down to negative 1. You got negative 5 over positive 5, maybe? Okay, because I was going to say, I have a feeling, and that's fine too, because as long as I have one of each, that absolutely works. So good, you tested it out the other way, and it still is working for us. This is a good thing. And that is a negative slope, that's true. So let's just do a couple more just to make sure we're going all right. Make sure there's no other information we want to put. Okay, because right, here's my y's. So I could do 7 minus 5. We did 5 minus 7. That's okay. My x's, if I do it that way, be minus 8. Yeah, now here's one we got to be careful on. Because some of you will look at that, you'll go, oh, 2 goes into 6, so it's negative 3. But the bigger number's down below. So when I reduce this, okay, it still will end up in a fraction with the bigger number on the bottom, like it is at the start of the problem. Okay, but if you did the 8 first down here, I'd do the 5 first up above. So at 5 minus 7, I'd get the negative up above. So as long as I'm getting a negative in one of the 2 places, my answer is the same. No, like for this one, let's say we were kind of talking like what you just did now. Let's say you said, okay, I did 5 minus 7 on top, Then I did 8 minus 2 on the bottom. So I'd get negative 2 over positive 6. But it's still going to come out as a negative 8. How do I get it to the 1/3 part? What can divide into 2 and 6? I'm just dividing each of those by 2. Yeah. And I can get the... Huh? Because whenever you're reducing a fraction, that's basically what you're doing. You're just dividing down by whatever will divide into both of them. Is how that's going to work. But I get the same answer either way. Okay? So that's how this whole slope thing works. Like I said, we're going to be spending a lot of time doing this. So, here's what we're going to do. We're going to take a minute. I've got you going on the right track. So this is the homework sheet that we're working on. So for instance, when it says find the slope of each line, just pick 2 points that they give you. It doesn't matter which 2. Connect them into your slope triangle, and then just count. So it's like, okay, if I'm going from here to here, I went up 1, that's positive. And I went right 1, which is positive. And that's all I'm going to be doing on these. Okay, and again, it doesn't matter which 2 points. Okay, so if I was doing number 2, maybe I want to do these 2. So again, I just kind of count. I go, okay, I went up 1. And I went right 2, which is also positive. And you kind of start to see, you're like, oh, okay, so what if on 3 I wanted to use these 2? If I'm going from here to here, I went down 3, and I went right 2, which is positive. So my up or down number always goes on top, and my right number always goes on the bottom. So for the ones where there's pictures, that's all I'm doing. Make my little triangle, find my slope. Okay. Nope, you still should get the same slope. Okay. Okay, wait. Which ones? Are you using these 2 this way? Are you on the same one? So like... Okay. So let's do it that way. So when I do it, I agree with you. I'm going up 3, so that would be positive. But I'm going left 2, which would be negative. When I'm on the x and I go into the left, it becomes negative. So I'd have 3 over negative 2. Because, yeah, my up or down always is going to be what goes on top. And my side decides what goes on the bottom. So now when I get down below, it may not look like that's all the same, but it actually is. Everything from 9 through 18 is done the same way. You're like, well, wait a minute. What's this thing in 9? I got this chart here going on. What's the deal with that? The chart is really just a fancy way of giving you coordinate points. So you're going to pick any 2 pairs. So let's say I'm going to use these top 2 pairs right here. I would use the slope formula with that then to find my slope. So for instance here, here's my fraction. And I go, okay, so my y's are negative 3 and 0. My x's are negative 1 and 0. And I'm just making my slope fraction. Negative 3 minus 0 is negative 3. Negative 1 minus 0 is negative 1. But what happens when you have a negative divided by a negative? It becomes positive, so it's 3 over 1. So if some of you like to get into a habit, I would just keep using the first 2 pairs each time. But that's all they basically are. It's like they gave you a 3rd pair as an option if you wanted to put them in there. Yeah, I was going to say, they're not the same though. Okay. But whenever you're down here, just a reminder, I think before I'm done here, we're going to give Mr. Slope Guy a tattoo of this formula on his cheek. We'll see here. But that's all we're going to do here is we're just going to keep doing the slope formula like we did there. So like if I was doing 13, the order of the y's doesn't matter as long as I'm consistent. Okay, as long as your y's are on the top, whether I do, so here's my y. You can. You could. Because all that's doing is it's making sure you label, because sometimes what people like to do is they'll look at one of these and they'll be like, okay, so with my y's, well, I'm going to do 4 minus 6 here, and then they decide for the x's, well, I'm going to do 4 minus 3. Well, I can't keep switching the order of the pairs. Yeah, if that's the first y I use, that's got to be the first x I use. That's the key. Because then when I reduce it, then I go, ooh, negative divided by negative is positive. I still get the same answer no matter which way I go. But I just got to watch for my signs and stuff. And I believe, if we flip over, it's the same thing going on. Up at the top, you just want to find the slope, and again, just use the points that are on your lines they give you. Okay? It says, say if it's positive, negative, 0, or undefined, Mr. Slope Guy can help you with that. Find the slope in the middle, and then use the equation down in the bottom. That's kind of our work with slope on this. Yeah, up at the top, you are just writing negative or positive. I got it a little overdone here on that. But here's the one other thing I think I'm going to put on Mr. Slope Guy here. Change colors. I think Mr. Slope Guy needs the slope formula on his face. So we gave him a little tattoo here too. So that's what we got working here with these. Like I said, you can use Mr. Slope Guy on anything. Yeah, you can switch the order. That's okay. Yeah, you can write y1 minus y2 and x1 minus x2. It'll get you the same answer. That's absolutely fine. So then we'll keep going with this tomorrow, and maybe we'll find something else to add to Mr. Slope Guy.